never closed. You guys probably saw it. You guys probably saw it on the news and probably saw it on the. I mean, nationwide people that Florida never. If it ever shut down, it was basically in specific places. But I would say like part of the state, some parts here. I went out. The traffic was insane. People eating, going into. I went to a store. Actually, it was bizarre. There were like glasses everywhere. Like you can when you go to buy something, there is like a glass, and then you kind of put through the product. They check you out, and then you have to. They won't let you in if you don't have a mask. And then you're like bombarded with all these messages that you had to be 6 feet away from. It was like being in a movie. It was weird. Um, and you guys saw, if we're here a few minutes ago, we have a person that is actually in a coffee shop and is open for business. So the reopening is happening. Not sure how this will go, but at least from what I am right now, we have to see. I mean, there's nothing to tell Florida, judging by how many people are so out and how the shelter in place was followed, we should be like New York, and we're not. So I don't know if it's the heat or the water, but definitely, or we're too lucky. But definitely, is it or is it different? It seems like as soon as they say we're going to reopen, everybody said, okay, fine, we're going out now. So as far as California goes, we're going to continue the meetings online. We have plenty of new content coming, and we're gonna have the Cobol CTF, we're gonna have the Ponago. We're gonna have today. We're gonna have the Owasp top 10 API, and there's other wonderful content. We're gonna have container security, drone security. So in touch with us. Join our Slack channel. If you email me at info@hack.org, I will join you to the Slack channel, which is basically where all of us are communicating. If you were affected by the layoffs, I've been hearing there's been some layoffs. Not sure how California is doing, but in Florida, I have heard of some layoffs already. There are plenty of remote jobs, mostly if you're in security. There's quite a bit of people looking for infosec and security engineers. So if you go to the hashtag job offers channel in Slack, there's plenty there, plenty. And if you need a referral, just ask us. Most of us, may not. Most of us, I notice that sometimes people don't publish job offers because nobody's responding. Because before COVID, pretty much everybody was employed and happy, or it was easier. So I'm assuming that some of them will be able to give you some guidance. So there's the info. If you send me an email, I will join you into the Slack channel. We will advise when we're going back. Again, the reopening had just happened. I'm not sure where California is going to follow through, but we will definitely will be on top of this. And when it's safe to go out and go back, absolutely, I will contact the library and we will get the ball rolling. A kind reminder to please mute yourself and don't put us on hold because then we'll hear the music. So that will have to mute you. Other than that, I'm going to let the presenter decide if she wants to take questions initially or at the end. Today we have Owasp Top 10 API. And with that, I'm going to give the floor to Kavita. Kavita has been wonderful to come on with this presentation for all of us. And I will let her introduce herself, and then we'll take it from here.
Hi, everybody. How are you doing? I hope you had all your lunch energized for this talk. Today, we are going to cover the Owasp Top 10 API. So, Rod, you're making me presenter now?
Yeah, That's what I'm about to do. Well, it could be challenging at times. I'm sorry. At least for me.
At least we don't have to get Zoom bombing, right?
Well, you know what? I wouldn't say that soon, right? So let me make her Kavita. Here you are. Thank you. Change role. Presenter. There you go.
Awesome. Okay. Able to see my screen, everybody?
Yeah.
Can you hear me? This is Samina.
I don't see your screen yet.
Yeah, my video driver has an issue, I think.
So wait a minute.
Rod,
So-
I had one question.
Yeah, go ahead.
So are we keeping the previous meetup online recording somewhere? Because my calendar notification did not have some of them. And I got this one, but not the other ones. I was wondering, are there any link that we can share that I can look at the older meetups that I missed?
Yes, if you go on YouTube and you type Pacific Hackers in your search, you will find our YouTube channel. Every single meeting that we're presenting is being recorded. Like this one's being recorded, and it will be uploaded sometime after it ends.
Okay, awesome. Thank you.
All right,
I just wanted to make sure I get the answer before we start. Thank you. Yeah, go ahead. Sorry.
Sure. Go ahead, Kavita.
Yeah, can you confirm somebody are you able to see my screen now? Okay, awesome.
Yes, we can.
Okay. So today we're going to cover Owasp Top 10 API. And a little bit background about me. One second, I'm trying to do this. Okay. So my background, I'm a software engineer. I was a developer for a couple of years before I stumbled upon the application security area. And then I kind of discovered myself, like I like to break things more than the building. So ever since like 8+ years, I've been in the application security, anything in AppSec, like from threat modeling, SSDLC process, the tooling, security testing tools, like SaaS test, SEA, the vulnerability management, analyzing, and shift left, managing security champions program. So my area is I like to work on the application security. So that's a little bit background about me. And yeah, hold on for a second. I'm having some issues. Yeah. So before I dive deep into Owasp Top 10 API, I just wanted to give you an introduction. Why do we need API security? Is it different from the web application security? To understand this, a simple diagram like how the API got evolved. Like back in the days, traditional web application, do you see like a web app or calling an application server or web server? So the whole like functionality is embedded like for each HTTP call, like the HTML is being returned to the client. So there is a tight coupling between the client and the server, and the state is maintained with the session ID or similar cookies. So it is just a plain, straightforward communication, which no extra layers on it. And then it evolved to a single page application, like I would say early adoption. Although I put API in the box, it is just for like abstract. Here, the web application, like a static content and a JavaScript, which has like a single functionality API, like the whole data is returned. For example, like one functionality, you want to add a user, like a retrieve a user, you call the web server, that functionality backend processing, and return the whole response back to the client. So this is also a little bit of client and the API are tightly coupled. So moving on to, like you see the single page application, and there are multiple API endpoints. So this is where I would say like the application authenticates a user with some type of a cookie or a token for making sense of the API calls. Like here, like there are multiple, in one particular web page, you might call multiple APIs for every functionality. For example, if I wanted to see a user, like whatever the product that I bought and reviews for the product, it would be like maybe multiple API calls on the back. But all these are like the results are filtered through the client. So eventually it leads to many consumers and many providers. If you see this diagram, there are many types of applications: single page applications, SaaS applications, mobile apps evolved, and partner APIs. So then the API gateway came into the picture. So API gateway, like that's kind of an entry point that manages like the backend, all the API, like one-way access. Like it can call multiple APIs, which is in-house, internal APIs, also public-facing APIs and third-party APIs. So as things get complex, you see this web application attacks surface is not applicable for the same API attack surface. So they are a little bit different, although can be some attacks are common, but then API security needs a special attention, especially when there is a mobile applications and the user interactions are more common these days. So with respect to web security, the most of the data processing, they done on the server side, and the web page is sent to the client browser. So back then, for this type of the web application, WAF played a major role in blocking the malicious traffic, analyzing the malicious request, and blocking the IPs, etc. But when it comes to, I think somebody is not on mute. Can you please go on mute? Yeah. Okay. So going back to API security, so evolution of mobile apps, microservices, and the more and more richer user experiences, there is like more attack surface on APIs that we are going to see in the session today. So bots and malicious actors are shifting from attacking the websites. Now there are more targets on attacking the public APIs, because APIs are the data, like they can store your data and they can handle state between the sessions. And there's new technology, like say, how do you secure API keys? There is always manipulation around these areas. So exposes access keys, tokens, etc. So all these leave a wide range of attacks. So I hope that you got an idea about like why the web and API security is different, because when you develop a web application, it's just not enough these days to focus only on those web issues. You have to pay special attention on the API during the design phase itself. So now I'm coming back to the top 10 API. What is top 10 API from Owasp? I'm sure everybody is aware of Owasp. It's a nonprofit organization. They have like a top 10 mobile, top 10 web attacks documented, risk documented. So this Owasp top 10 API or API is this document, or they released it in 2019. It's pretty recent. So they kind of mapped all into these 10 buckets. We can go each and every one in detail, but at a high level, you can see these are the 10. So yeah, first, the broken object level authorization. So what is it? When you think of calling an API, in the screen, you see a simple GET request, get user details for the user ID 241. So from the, like when you develop this API, like what if you manipulate an ID in the request, because the server does not fully track the client state, instead, like whatever the functionality you write or retrieving the user details, it relies on the parameter, right? Like the user 241, like for that parameter, you go hit the database, get the details for the particular user. So now from the attacker mindset, what I would want you to think is like, what if I can pass 242? Will I be able to get the data? So what kind of mechanisms and controls we need to have in place? And what is the issue here? Like you can clearly say if my API, like if I pass another 242, another user, will I be able to get those response for that user successfully? Let's dig into another example. It's similar to the previous one. I'm just doing a post here. Product reviews. So the application, the user logged in, and the user 140 is supposed to update his review. He had a very bad experience. He wanted to review the product 1 point. But is there a way that the attacker can directly hit the API, manipulate, and then change his reviews or make some other users' reviews? Like again, 141, instead of the user updating his own review, can he update into another user? So what is missing in here? It's pretty much the access control checks are missing. And also, if you see, we are not validating whether if the logged in user has the same performed to same requested action on the requested object. To give you a more detail on this, if you see, we are not checking, if you are not checking in the API, whether this logged in user is the same user that is going to perform the action on the particular object. So if that check is missing, authorization check is missing, it's going to return whatever the data for the other user. Before I go into the prevention, I would like to give you a real world attack that happened on this particular issue, the broken object level authorization. This is the Uber account takeover happened in 2019. So step one, I would like to go over that act and to see if you can understand how exactly it happened at a high level. If you see this request, this is the API request, one of the API, any phone number that you give, and the response gave you an additional information for that particular, just by giving the phone number, it mapped a UUID for that particular user. So with this API, the UUID got leaked. That is the first step. And using the UUID, there was another API, a marketplace, RPC, whatever, that if you see on the left side, the user ID, whatever you retrieved in the earlier step, the request, and send the API malicious request, whatever you're not supposed to, and then you got a successful API response back with the PII data for that particular user. So pretty much what happened here, you were able to get all the PII data for any other user with just passing the phone number. So how do you prevent it? So one thing to prevent it, it's pretty easy. You see, like use GUID instead of UID. It's not GUID is not guessable, whereas UID is always guessable. Also, you have to include the proper authorization mechanism that relies on the user policies and hierarchy. But you have to check in your API whether the user that is logged in is the same user that is retrieving the user data. Here, it is not the case. In the first example we saw. So authorization check has to be in every function, just not one, but whatever the function that you do, you have to make sure just not the authentication is satisfied, or whether the user has authorized to do some action on the object. So one other thing you can do, developers can write test cases early in the development. So the second one, the top two is broken user authentication. The first one is like object level. So the second one talks about authentication. So when you talk about the authentication, API endpoints for authentication are treated differently from the regular endpoints. Like there are multiple API endpoints, obviously login, add user, so many API endpoints. But what I'm mentioning here is there are few API endpoints that require special attention, just not login. Maybe there are other APIs like forgot password and reset password need special attention to and should be protected same as login. We are going to just see a use case why it is important, because it allows the credentials, like with the credential stuffing mechanism, say you want to reset a password. So the API request and response accepts request, username, password. So what if an attacker can perform a credential stuffing on that particular API by sending in multiple passwords, username and password combinations in the API request? So how does your API going to behave for that particular use case? You have to think about it. And then, so even when you are implementing the JWT tokens, there are possible that in the developer, when they are implementing it, they think it's safe, but then there is a way, one of them is like, if you say the algorithm is none, that means it's pretty much like it's, you're not like signing up properly. So these are some of the flaws. And I've seen auth tokens and password is being passed in the URL. And also weak encryption keys. The keys are not good enough, the length, whatever it is, weak hashes. And in this case, no account lockout. So what if like I keep trying multiple times? Do I implement a proper account lockout? Like maybe depending on your application, whether 10 times, 8 times, 6 times, whatever it is. So these are the good points to think about when you consider the authentication part. I would like to go over this example. Say I am doing a post API call, like a on a reset password. Like this is an API that would send me a verification code to my mobile SMS. The verification code is like 6-digit, but if there is no rate limiting the API, this is suspected to brute forcing, because you can attempt again with the help of the script, try X times with the various 6-digit code. Eventually that will lead to the reset password. Again, we talk about the rate limiting. Without rate limiting it, this would break. So what is the prevention for this issue? Implement multi-factor authentication whenever it is possible. That is just not enough, but that's a good starting point. Just do a multi-factor, and also definitely for an anti-brute force mechanism, you got to rate limit your API. You got to know your API. So just rate limiting is used to control the amount of incoming and outgoing traffic from and to the network. Say if you say you're letting your API allowing like 8 requests per minute, then anything more than that, it would be an error. So you can have some kind of protection over here. And we talked about the account lockout. And there's another CAPTCHA to consider. And also don't reinvent the wheel, use the standards for authentication and token generation, password storage. So now moving on to the third top 10 Owasp API, excessive data exposure. So what is excessive data exposure? So this happens when you just sniff the API traffic, looking for the sensitive data, what is in there. Just by sniffing, if your API returns some responses more than it is supposed to return, like consider I've seen this a lot, like when you develop or design an API, so we just like, okay, this functionality, this is the request, and this is the API response. But there are a lot of cases we send more because we query it from database, we don't if you don't consider what the client is expecting, and send the whole bunch of response back to the client and expect the client to filter it for the display, then it is a problem, because you cannot trust the client to display. Somebody can hit your API and can read your data, sniff your data. So when looking at the example, it's very simple example. I just wanted to read my user reviews, get API user reviews. So here the response, if you see the response, you're supposed to give just, this is the user and this is the list of reviews that he had written, like say 5 reviews. But just because the way it is developed, I would talk about why it is coming soon. The whole user object is present as a part of the response, and this is not pretty earlier. This is pretty common. People used to do that because the ORM framework, like when you bind it, it just like until you filter it out, it just sends the whole object back to the client. And if you just do a like the object dot to JSON, it displays the entire data, which including the PII data available on the user object. So that's why what you have to do is be conservative in exposing the data. So always use the principle of least privilege. Expose only the required call for the API call. In the previous case, the ideal would be just to display the user ID. The request like, oh yeah, we need the reviews. Just the response should be like user ID and the reviews, say 5 reviews. That should be the response, rather than not giving the whole user object back to the client and the client filtering the reviews. And so that's not the ideal way to do. This also prevents accidental exposure and also some disclosure of personal information. And sometimes you can even like figure out by correlating the data from different data sets. So it's always like good to follow the principle of least privilege. Another real world example, the Twitter app bug was used to match 17 million phone numbers to user accounts. So this is like December 2019, a design flaw in Twitter Android API. A high level, the API, the Twitter API, one of the API, you could upload a list of bunch of phone numbers. Somebody, a researcher found this one. It could accept a bulk number of phone numbers and the account match the API. So there are some validations, there were some validations in place. Basically, if you give like consecutive numbers, it would throw errors, but there was one validation bypass, and he was able to upload a bunch of phone numbers, millions of phone numbers, and it matched to the user account, user information. So upload the entire list of generated phone numbers through Twitter contacts, upload feature, and fetches the user data in return. So ideally, it shouldn't have returned the response, the whole bunch of user data. It was just an upload functionality. I don't know much in detail, but then looking at this, it's like excessive data exposure problem. So how do you prevent it? Pretty simple, never rely on the client to filter the data. Always you just return whatever is needed for that particular use case. And the best thing is like no tool would figure this out, but the best methodology or what you want to do is just review your APIs, what you're sending and what you're getting back. Some peer review that would help. And the developer should ask this question: who's consumer of the data? Who is the consuming this data? Like instead of just, okay, I'm going to return it this one, ask these questions: who is consumer and what is it? What data is required? Ask these right questions and avoid using those to string and to JSON. Eventually end up in the log files, which would be an internal thread. So, and as we talked about, return only specific properties and always use the data classification if possible, depending on the use case. And moving on to number 4, it's lack of resources and rate limiting. So this issue happens when your multiple concurrent requests, it doesn't require any authorization or anything. It is just like DDoS attack, right? Like exploding your resources. So sending multiple concurrent requests by using like a cloud resource or your computer, and see and observe how the API responses respond back. This is clearly a denial of service attack. So because multiple clients compete for the resources at a given time. Now look at this example. The request is, I just wanted to see the list of users in a page, and this is the request, and I am limiting it to the size 100. So this is my functionality. For example, when you want to develop something like this, developer should ask questions. So what if the attacker changes from the size like 100 to a big number? How does my API respond back? So it would be unresponsive, maybe buffer overflow errors can happen, denial of service can happen, but how do you protect it? So this is where the rate limiting comes into picture. It is a best way often to limit how often the client can call the API within the defined time frame that I told you. Like each API is very different, and you can set the API rate limiting. This is the API used frequently. The other APIs are not that frequently. So you can define the APIs like I need to serve my APIs like like 100 requests per minute or whatever. And the other one, server-side validation on control parameters. In the earlier example, we saw the size 100. Make sure you check, because it is a user parameter. It can be manipulated. So check for the parameter and also check for the maximum. What do you allow? If anything more than that, throw an error message. Now moving on to broken function level authorization. So this is a little different. This is a functional level authorization issue. The good example would be, so there are a lot of API endpoints, and there are few endpoints that you never intended to expose to the public. So the attackers sending the legitimate API calls to the API endpoint, they should not have this happens a lot too, because the way in which the CI/CD now, it's pretty quick, the way in which the functionalities are turned out. There are a lot of old API endpoints, or there are APIs without documentation. Or there are few higher level permissions API which are not supposed to exposed or exposed. There's so many ways it could happen. Just because it is the way the APIs are structured, if you look at REST APIs, I can tell you, like, API users 100, it is a GET API, right? But you're not supposed to do a delete on that particular the delete request. But then if you don't disable the HTTP delete, then you're allowed to do a delete. So these kind of little information or configurations might be missing that the attackers can take use of it. In this simple example that I am supposed to do only the get, but since delete is not disabled, the attacker or anybody can able to perform a delete operation on that particular user. So this is REST standard. It's easy to guess. So that opened a attack range. And also, yeah, simple example would be the URL string If there is anything that changes from user 100, what if I change to admin? What does it return? So all these questions, like when you develop an API, you should ask yourself. So can regular user access the admin endpoint? Can the user can perform sensitive actions where supposed not to say from get to delete? So this open up this function level authorization. I can explain with another example. In the ride sharing app, there are different APIs available: driver API, rider API, admin API, but you are not supposed to expose your admin API. That was the plan. But somehow the attacker got hold of the admin API. The user can perform a delete user, and attacker can perform a delete user too. It's the function level authorization checks are missing. How do we prevent it? So deny all access by default, requiring explicit grants to specific roles for every function. Again, this is something to do with the authorization, like policies and roles, because it's getting complicated. In this example, you see the same functionality, but different roles like driver and rider and admin. So getting a little complicated. So you need to have like the access permissions and roles defined properly in your code. And also implement that. The solution would be like implement the solution in the code, check your configurations and API gateway, disable the unused HTTP methods. I see that a lot. A lot of HTTP methods are not disabled, and then the attackers getting use of those. And have authorization checks in place. Now, moving on to mass assignment. Mass assignment is a problem where you bind the client data to the data models, the ORM, with the use of ORM models, whatever the data that collected from the user, and then it mapped to an object automatically. That was an advantage for developers when you were working on it, that was a feature, and that is getting exploited, I would say. It is by blindly relying on ORM. So this is because the framework encourages the developers to use automatically bind from the input to the object that is going to be saved in a database or a drive. Either guessing the object properties or exploring other API endpoints or reading the documentation. Anybody can figure out how your API is working and what are the properties available. So can I manipulate this? That's the source of the attack. By not preventing the client from changing the values, like it should be only read-only, but then you somehow make it right. So an example I can show you, the next one, say there is a form, user, a password, and email. You collect it from the user input. And this is the user object that is being bound to, username, password, email, and there is another a Boolean value is admin, true or false. It's being there in the user object, right? So when you do an edit user, you bind the form value to the user automatically instead of manually setting it. That is the issue here. That is the mass assignment issue here. So when you do a post call, API call, what does it do? Like anywhere, the original request will be the username is something, password and email. But now by just sniffing through it, I am figuring it out. Hey, there is another variable inside the user that I can leverage, and it says it's admin. So what if I try with admin true? And that is the whole issue, right? Like you're able to edit a user as an admin. So that's the mass assignment issue. So one of the real world attack happened is a harbor. which is on 2019 a cloud registry service. This is a popular open source system for registering the container base images. Again, it internally used ORM for writing the objects to the database, as we discussed in a lot of places. So researchers found that the user objects have an admin role flag on them that directly maps to the field. So basically, they got hold of the admin variable, and they were able to tamper the base images used in the company. So that's the mass assignment problem. What could be the prevention mechanism? Do not bind automatically the client input to the objects. Just whitelist only the properties updated by the client. So in our example we saw previously, we would just manually set only those 3 properties and not binding the whole object. So how is everybody doing? Is it you're able to follow through? Just making sure. Hello?
All good so far.
Okay, nice. Okay. Now the security misconfiguration. So this is a pretty standard, same as Owasp issue 2 in the web application, nothing strange, and it is applicable to API also. Any unpatched flaws, common endpoints, unprotected files like that you can directly use to gain unauthorized access. Due to the misconfiguration that is happening, that can expose only the sensitive data, compromising server, all sort of configuration issues that we are pretty much aware of. So this happens due to the lack of secure headers. And we talked about HTTP method not able to disable few, and we are exposing more. And in case of web application, again, course policy is misconfigured that you're not supposed to access, but the course policies are like, you can define a course policy, but it is like misconfigured, like what APIs can access if you give a star on it. So that configuration can be is a problem here. And again, cloud configurations. I would see a breach here, like Equifax. Everybody is aware of the lack of secure headers, unpatched Apache struts. Again, the HTTP header content type that was being manipulated with a malicious payload. So, and the alerting system also failed due to a security certificate that has been expired for 19 months. So, and then 148 million customers got impacted. So there's a lot of misconfiguration issue here, including not maintaining your certificates properly. What's the prevention? It's hardening systems. There might be some there must be a way to automate your configuration, to find the configuration flaws, you can think about it, and disable the unused HTTP methods. We saw that earlier, make sure your certs are in place. So, and also review your S3 bucket configurations, API stack, across the API stack, the configuration, orchestration files, everything comes under this particular configuration topic. Coming back to injection. Injection, this is also kind of the same attack surface as in the Owasp top 10 on the web application. Yeah. So this happens because the client data that is coming is not validated or filtered or sanitized by the API. Again, the same issue is when you have an input that is not being properly sanitized and your API is accepting that input without that sanitization, and the input is being passed on to a query, which can lead, concatenating a query, and then it can retrieve more than what it is supposed to. A simple example would be if you see a delete API bookings, like you are supposed to pass delete a particular booking 678, but the attacker was able to intercept this request and change the booking ID in the query string parameter. So just by manipulating in the query string parameter, he was able to manipulate and delete another person booking. So again, sanitization of the input would have helped here. Don't trust any user inputs. That is the rule number one, and sanitize all the inputs that is coming into the API. So that would be the prevention. And encode properly, decode properly, special characters should be escaped. And you prefer a safe API that provides a parameterized interface, use prepared statements in the backend to retrieve from the tables. So the next one is the improper asset management. So this is again a very common issue in the development. Mismanagement of API assets in this fast CI/CD pipeline. We got to update so many versions very quicker, so we don't decommission the old version properly. And any new fixes, security fixes, goes into the new version, but the old versions are left behind. And still there are some active requests going on that endpoint is being serviced. So that is a core problem in this issue. And also there are like so many APIs, like and if you're not in the API gateway, there are how do you discover them? And having not documented API endpoints, old team working on some APIs long back, having no documentation. So the API discovery is a problem here. And the old APIs that are dormant and abandoned, but still are in active servicing. And also the same security standards is not being in production and non-production environments. For example, I would just, in this picture, just say V1, get users, and I have some other new functionality. I released a V3. Those two are active. So in the real world now, experimentation, you wanted to introduce a new functionality. So you created a new V3 get users that might be the new latest API does some get more details or whatever the functionality that you want to develop. So there are some users like with experimentation, like 80% is using V1 and 20% users are getting the V3 request. So both of them are active. And consider this case, there is a security issue popped up and you fixed only on V3 and you did not fix on V1, what would happen? Still some other attacker can get hold of V1 and manipulate it and exploit that issue. So it is always a best idea that whatever the fixes that you put in, it has to be get into all those API versions. And also there is, say, a third one, it's pretty old API, it's not discoverable, that nobody knows what it does, but it is serving some traffic with no documentation. It's out in the world for exploitation as well. And this is pretty common when you do a Google that for a particular, like you will be able to find out all the old API versions, etc. It's out in the world. And the other example would be unknown API host. For example, DevOps, they build something for them, but nobody knows it. So there could be some, again, it's a discovery issue. And the real world example would be a company called Just Dial. It's a local search service in India. So it got breached on 2019. Just because, again, old unprotected API was left in the world that leaked the data on all their users. So basically their latest version did not have any issues, but the old version had some issues, and the attackers were able to exploit it and get the user information. This one is pretty challenging and time consuming for developers, like just to make sure whatever the active APIs are serving the same. And how do you prevent it? Again, it requires some work. You need to have the inventory, prod, staging, what are the API host, generate API documentation using open standards. These days, it's like a lot of open standards are available. Just do the API documentation, make them available. And then protection measures, as we talked about, not only for prod, just do the same thing for the other environments, and move to new API secure version, decommission the old one whenever you can. And the last one, insufficient log and monitoring. This is pretty standard. You leave a lot of information in your log, and also you don't monitor enough. Those two problems. So video sharing platform, Daily Motion, hit by the credential stuffing attack. Again, the same problem is like there were no alerts were triggered. There was no monitoring happening. After the customer complains, then the team started looking into it and they found this attack. Like, oh, like, okay, then they reached out to the customers and for the password reset, etc. So yeah, like you got to monitor, and logs, you got to make sure there is no PII information or anything sensitive information is being logged as well. And the prevention, log in the failed attempts, prepare some alert, use like SIM tool to collect and aggregate the logs, monitor, create alerts, dashboard, anything that helps on this particular issue. And these are the references I included. Thank you. That's all the Owasp Top 10 API. I'm open for any questions if you have.
Any questions? I think somebody was asking how often this is updated.
Yeah, so this 2019, like it got released a couple of last year, and then I know the team is actively working on and updating the standards, and also they are working on to release a vulnerable API that everybody can just use to learn, like how WebGoat was used to learn the web application attack. So yeah, this team is pretty active and working on the initiatives, and there is a group working on the Jira issues as well. Yeah.
I have a question. What tools and techniques do you use to evaluate the API endpoints? Tools and techniques. And it would be nice if we have an example to illustrate.
Yeah, so I think, okay, there are a lot of like issues that I talked about, like except for the business logic flaws, any DAS tools were able to figure out a lot of issues too. Not mentioning any one in particular, but and for business logic flaws, unfortunately, there is not any tool that will figure it out. It is all about the pen testing. So I would say a lot of issues in the API so far have discovered in pen testing. Apart from the basic ones like HTTP headers, and there are some rules around that. Like you can figure it out with these DAS tools. But for the API security, I feel there's a lot going on in the business logic side. Like you've got to validate. There is nothing like one tool will figure out your authorization flaws or anything like that. So it is a lot of manual review and pen testing.
There's another question here. Any best practice recommendations you have for authenticating mobile apps?
Sorry, can you repeat the question?
Yes. Any best practice recommendations for authenticating mobile apps?
Yeah, like use the OAuth, like the standard framework, OAuth 2.0, integrate that, and then how you protect your access tokens, and yeah, that's my answer. Like use a like whatever the framework that is, instead of like reinventing yourself, use a popular framework. Like I have used OAuth 2.0 framework.
Here's another question. How is rate limiting done in practice? Doesn't that consume significant compute resources?
So can you elaborate on this question?
Yeah, this was Sean. Sean, can you speak up? Mute it. Sean, you there? Okay, let's move on until he comes back. It was mentioned in excessive data exposure about sniffing API traffic. How's that possible?
How is it possible? If you, I mean, get hold of that API, like, I mean, I'm just thinking like, say something like you bypass and then get hold of the API and then get the sensitive information. So I have not done much on the pen testing side, but yeah, that's one thing that I could.
And then there's another. Yeah, I think that's the last question. I think Sean is having issues with his mic.
I have a question, if that's okay.
Go for it.
Yeah. So you mentioned earlier about the CI and CD, the continuous integration and development. So I was wondering how would you like if you share with us like what like the tools or the framework that have been used during your experience, that and how it does check the APIs, like performing security maybe check or gate checks. I'm just really curious.
No, I was mentioning about the CI/CD pipeline is like, I mean, now the continuous integration, people are releasing more features faster, and how the old versions like get abandoned. So with that perspective, I was mentioning the CI/CD pipeline. Like you got to move fast. So there are a lot of like old APIs getting abandoned, undocumented version. But is this your question to answer, like regarding what tools is being used, or is there anything in particular?
Yeah, thank you. I'll be interested just to you explained the previous slide. That's nice. But I'm just out of curiosity, what would be like there's so many frameworks, but from your experience as a security engineer, what would you like see the like a pipeline, a framework that did work for you, especially with that implements like security gate checks.
Okay. So not in particular with API security. So in general, the gate checks, anything with this, I've done like, I mean, any SaaS checks, also automated like a Zap tool I have integrated that was pretty useful. I mean, I'm just not talking about API security, but in general, the pipeline, when you commit the code or before you commit the code, the SaaS kicks in, where you can, the developer, when before even committing, there is an ID plugin, if it is available, you can validate your code for the security flaws, because SaaS is all about the rules. And there are also, you can do in your pipeline, like when you merge your code, it is all how you want to integrate it. Before you merge your code, somebody, I mean, the SaaS scan can run and and give you a report of whatever the security issues. And the next is the DAST. If you wanted the live request, malicious request, like how the responses are, and like the lot of issues that I've spoke about, like headers and the HTTP methods are not enabled. Those can be caught by the DAST, or it can be like a Owasp Zap. Owasp has a Zap tool. You can try that too. It does both active and passive scans. The third is the SEA, software composition analysis. So any code that you push in, you want to make sure that you're not using any vulnerable libraries in your code base. Like so, yeah. So those three I would recommend to start with.
There's another question here for rate limiting. Can you use API gateways that offers this?
Yes. So I have not worked in detail on that, but I know that yes, you can use API gateways and do the rate limiting.
Any other questions? Okay, it says there's another question. We're getting NetSparker. How good would that be for API DAST security?
Can you repeat the question, please?
Yes, it says that they're getting NetSparker, which is a tool for testing web services APIs. How good would that be for API DAST security? Dynamic, yeah.
I have not used the tool, so I cannot comment on that. But whatever I've experienced, like the rules, like apart from the business logic flaws, I mean, business logic, like the object, we talked about the object level authorization, function level authorization, like all those are like the DAS tools would not be able to find it, or any other tool like or I have tried was not able to find it. Those are all manual reviews and testing. You got to work with the development teams, like security person, or the developers have to be aware of it. Checks are like business logic. So, but other than that, when I talked about like the security headers are missing, or any HTTP methods disabled, all those, like DAST was able to find it with respect to this API, and some sensitive information also they were able to figure it out.
Here's another question. How would you differentiate DAST from threat modeling in terms of web app security?
Okay. Okay. Threat modeling is completely, different from DAST. It's like threat modeling is like when you do an architecture review for your web application, say, threat modeling is just another term, right? Where we think from a different perspective. When we are architecting, we draw some diagrams, but then threat model is a way that you have you draw, or like you discuss about what are your applications, what are your flows inside the application, and what are your trust boundaries. So it is a design way of thinking that what could go wrong, and there are so many principles that you can apply. I follow STRIDE, which is from the Microsoft Adam Shostack. Like so I follow the STRIDE principle, like spoofing, tampering, information disclosure. So apply that model to figure out the threats early in the development phase, before even you start writing code. You sit together, put a diagram, how the process flows from your application input and output, and then trust boundaries, and you do the STRIDE principle, whether spoofing can happen, what could go wrong. So that is totally different from right now. Threat model is like I haven't seen. I use like this is manual threat model. I know there are tools available, but I have heard like they are also like not up to the standard, like finding all the vulnerabilities. So it's the best way to manually sit and threat model and record all the threats and the mitigation. DAST is something, again, it's very different from that model. You configure the URLs that you want to test, and basically the rules kick in and it sends the malicious request, like scroll through the pages and finds out the actual vulnerabilities, and it will give you a report of how this flaw could be exploited and what is the request URL and what is the response that you got it.
Good answer. Any other questions?
So I just wanted to, end the talk, like, so any automated testing API, I haven't explored that much, but then I would emphasize at this point, like, a lot of issues that we talk about, it is like just a manual review or asking the right questions, like, so like working with the team, like, hey, this is the request and this is the response, and sitting and talking what the client, what is the functionality and what is the flow and who wants this data, and seeing the actual response and asking questions like, hey, is this a PII data? If you see something fishy, just drill down the API response and talk to the teams, like, is it needed? Like, if you see anything sensitive, like, hey, why is this needed? Question that. And that, and then authorization. How are we authorizing? How are you limiting the access? Like, it's more like manual review that help a lot. Yeah, that's one thing that I want to share, my experiences with the API. A lot of things, like during the development, before you develop, like you ask questions and you figure it out a lot.
Well, thank you very much, and thank you very much, everybody. Remember, if you send me an email to info@bhack.org, I will invite you to Slack. We have amazing and exciting content coming up. We're going to have the Cobol CTF, the Panagoshi. We're going to have container security, drone security, and many others. Stay tuned. Check the meetup.com/Pacific Hackers. Again, Hacker Specific in Twitter or FAC Meetup. And we'll stay in touch. And I'll thank you very much for attending.
Thank you for this opportunity as well, and thank you. Bye.
Thank you.
Hey, Rod.
Mm-hmm.
Rod, are we still using the PHAC channel on Slack?
Absolutely.
Okay, because I didn't see anything for today.
Oh, because you guys don't talk. If you guys don't talk, then I assume that you guys are not. I are not paying attention, not active. If you guys post stuff, for sure, we'll get it going. But you see the general, the threat intel that right now in the current disaster. But yeah, this is your channel, so please use it. And thank you.
All right, guys. Thank you so much.